Welcome, everyone. Thank you for joining us in what will be another exciting customer conversation at Distributed SQL Summit 2022. As a way of introduction of myself, my name is Michael Haig, and I'm the head of product marketing at Yugabyte. I'm thrilled now to get a chance to speak to another one of our Distributed SQL customers, and one that's in a little bit of the earlier days of their journey. So we'll get into to dig into their motivation behind why Distributed SQL made sense for them, and then peel back a little bit of how they approach the evaluation and the testing of things like YugabyteDB. So anyone out there that's, again, earlier in your journey to distribute SQL, still new to it, trying to figure out what are those first steps, kind of how do you get started on this journey, then I'm really looking forward to. I think this will be a perfect session, if you kind of get those insights from someone that's gone through that very recently. And to help with that, I am thrilled and honored to be joined by Lokesh Duseja, who is the Director of Digital Engineering at Bed Bath & Beyond. Welcome, Lokesh. Thank you so much for taking the time to join us today. And can you maybe spend a few minutes just kind of introducing yourself to the audience?
Thank you, Michael. It's my pleasure. Thanks for inviting me to this Distributed SQL Summit. I'm Director, Digital Engineering and Architecture at Bed Bath & Beyond. I have more than 19 years of engineering experience, worked in various roles, and I'm always eager to roll up my sleeves and get my hands dirty. I'm associated with Bed Bath for more than a decade now. Here, I'm focused on optimization and modernization of the digital platform to keep its architecture simple yet resilient, and one that can perform at scale.
Nice. And my understanding is when you kind of say that you look at kind of modernization, does that mean you get your hands into cloud, into apps, the data layer? Like you kind of get a sense to look at that full IT stack. Is that correct?
Yes, absolutely. As the owner of platform and optimizations to it, I have to get involved anywhere it demands.
Perfect. Yeah, that expertise will be perfect today, kind of to get that holistic picture. And then just for anyone that maybe some of our international folks that may be not familiar with Bed Bath & Beyond, can you just give a quick overview of who the company is?
Sure. Bed Bath & Beyond is an American-based company which was founded in 1971. We are an omni-channel retailer with a mission to provide goods and services to make it easy for our customer to feel at home. The company sells a wide assortment of merchandise in home, baby, beauty, and wellness market. Along with Bed Bath & Beyond, we have three additional brands, Harmon Face Value, Bye Bye Baby, and Decorist. Our culture is customer-centric. We strive to better engage with our customer wherever, whenever, or however they want to express their life interest and travel through their life stages.
Perfect. And so kind of for these discussions, I always like to start at the big picture, and then we'll start to peel back and get it a little bit into more of the database specific. So again, digital transformation, the buzzword that's been around for a while. Without a doubt, over the past few years, I mean, the retail industry, I mean, like many industries, have gone through tremendous changes, kind of higher customer expectations, a lot of focus on just kind of embracing just all new digital technologies and everything. As we talked about your role, you kind of alluded to some of these different kind of cloud and apps and databases, all these different layers that you look at. But kind of get specific to your role and some of those, as you think about those changes and how they've implicated kind of Bed Bath & Beyond, kind of how have you approached that transformation? Like what has been kind of the approach within you and your team, and what are some of those key technologies that have really been important to that transformation of you?
Sure. Over past 10 years with Bed Bath & Beyond, I've seen the e-commerce platform has gone through a few digital transformation or modernization already. First in 2013, when we moved from an old ASP.NET application to Oracle ADG commerce platform. Next in 2018, we we moved to headless architecture. We revamped our front end to React-based application. Then along the way, we moved towards progressive web apps and now adopting the idea of micro front end. And since 2018, we have been also actively modernizing our digital platform by migrating services to to cloud-based to cloud platform services which are Spring Boot microservices and deployed use Kubernetes. They use database like Firestore, Cloud SQL, Cassandra, as well as Redis. Now in 2022-23, we are in process of modernizing our core commerce platform, which includes workloads like promotion engine, catalog, customer accounts, registry, and cart and checkout to cloud-based microservices architecture. We chose Yugabyte as the database for all these workloads and Broadleaf Commerce as the platform accelerator. By the end of this current transformation, we expect to have faster website and mobile apps will show most updated data like prices, availability, etc. to our customers. We'll be able to run campaigns quickly. The services we expect to be more resilient, and of course, will probably save a lot of cost of operation as well.
Nice. Yeah, and you mentioned just some of those key workloads again. I mean, the customer accounts and shifting all the microservices and just I remember when I got married, my registry was with Beth and Beyond, so we definitely used your your services as part of that. So it's, again, that was a while ago, maybe before some of these initiatives.
That's good to know. I created my second baby registry with Bedbath as well. So yeah,
very nice. I know that one's very well used. That's awesome. Yeah, to think about. Yeah, that's, again, as we think about it, again, just the global nature, distributed nature of all this data, shifting into these new databases is great. And so maybe talking about the database, then you kind of mentioned kind of YugabyteDB, but just kind of a little bit more broadly then, as you are going through these transformations, again, a big focus with any organization like yourself, retailers, very data centric. It's the data, whether it's the transactions, the catalogs, the kind of coupons, the registries, all these have a very heavy data component. Talk me through a little bit of kind of how do you approach the database? What's the role that database plays in your transformation? And maybe how has that changed? I mean, as you kind of have these new services come on board, how have you had to react and rethink what you do with a database?
Sure. Database play a very important role, especially when we are moving from a monolithic to microservices-based architecture. See, monolithic applications have a monolithic database. Every component of the application shares the data, which may sound good, but it also creates tight coupling, and we cannot deploy any change independently. So it increases the time to market. To scale, we have to scale the entire monolithic database. And then performance also becomes a challenge, because with shared database, we end up creating huge tables and huge number of joins on these tables. So when we modernize our monolithic application to microservices, we must split that database as well, because there may be services which require relational database, for example. But there are services which will perform better with NoSQL. And some may even need an in-memory database, right? So with the splitting, we can scale easily, we can deploy changes quickly, and we can target to improve performance of specific services individually.
Makes sense. And talking about scale, I actually was having a conversation with another customer recently about this idea of how, as you think about that monolithic scale, you kind of are scaling vertically up. So you're looking for bigger servers, you're buying kind of the beefier servers, and at some point you kind of find yourself, whether you mean to or not, buying very proprietary, finely tuned, customized, and expensive hardware, which breaks a lot of the model in the focus of wanting to go to commodity hardware and cloud and kind of IaaS of just kind of using kind of just standard servers off kind of that come by the thousands, hundreds of thousands, as opposed to the proprietary systems. Do you kind of agree with that? Do you kind of see the same where there's a focus on just commodity hardware and wanting to find kind of just use standard servers that you can connect together as opposed to those kind of more customized systems?
Yeah, absolutely. There are practical limitations maintaining the monolithic database. One is hardware, right? So, and that's where there is a desire to move to a distributed database, because we can create a cluster of cheaper compute on cloud, and then create a logical database using those clusters, and which is really easy to scale. For example, if you want to scale memory cores of those compute machines, or even add nodes, pretty easy. So that's where there's always a desire to move to distributed.
Yeah, perfect. And as I said at the beginning, I want to kind of dig into you're relatively early on this journey. So maybe let's turn our attention to thinking about how you approach that database evaluation. And as you started to realize that you were breaking up into microservices, your database needs were changing. How did you approach this evaluation? And what were kind of key parts of that journey that you went through in rethinking the right database for your applications?
Yeah, rightly said, it's a journey. So first, the way we did was, first we identified the loosely coupled modules in our monolithic, and we migrated them to microservices using open source or native Google Cloud databases. Then we logically divided the remaining monolithic commerce modules into different workloads like promotion engine, account, catalog, order, registry. We then started the exercise of analyzing all the workloads that required relational data structure, workloads which can fit or can be converted to NoSQL for faster query times, and so on. Then we created a kind of rough architecture or a topology of the databases for different workloads based on their complexities, read-write frequency, and latency. We also looked at the fault tolerance, data consistency across regions, and so on. And thereafter, we started mapping exercise of the requirements to the available database options like Cassandra, Firestore, Cloud SQL. We looked at Spanner, CockroachDB, and of course, Yugabyte. And at the final stage was the evaluation part, where we evaluated these database to fit the needs of these services, as well as other non-functional requirements.
Nice, and we'll definitely talk about that evaluation here in a second. But maybe before I jump to that, as we think through just going back to the applications, I mean the workloads that were driving this. Again, ultimately, we live in a software world, and it's the applications that are kind of driving those new services in our business and what we're building all of this infrastructure, data layers, pieces for. What are some of those kind of key applications, workloads that you have, and maybe can you give a little bit of color of any kind of key characteristics that they have? Are you seeing that kind of those set of workloads different than maybe 5 years ago? So maybe kind of give us a little color on the workload mix.
Yeah. I mean, we know that the e-commerce space is ever evolving, right? The customer interaction with our application, which is today, is quite different from what it was, 3-4 years ago. Like accurate product inventory is essential for good experience. Performance is another area where customer expectations have changed a lot. So our applications and workloads have also evolved over time, and each of them have different characteristics. For some, strong consistency is required. For example, we have to show most accurate or up-to-date inventory for a product. But for other workloads, like profile services, eventual consistency is okay, since customer session is pinned to a region. So it's acceptable if updates are available to the other region in a few seconds. And other characteristics for some of the services are, high number of both reads and writes are expected, like our cart and checkout operations or live stages operations. But services like promotion engine, they're definitely a requirement of high number of reads, but the updates are very few. So these are different characteristics.
Nice. So then as we kind of think through this overall evaluation you went through, you kind of talked through looking at different databases, thinking through the applications that you have. What were kind of those requirements that kind of bubbled to the top of your list as those must-have things that you needed as you kind of got into the next phase we'll talk about testing?
Sure. The topmost requirement was performance at scale. Okay, we required a database which can scale horizontally, which the distributed databases are capable of, but they should also have the lowest possible latency required for an e-commerce application, right? And other requirements were, highly available, geographically distributed, and redundant database that can survive a node or even a full region outage with little or no data loss. And then there were other general requirements like support for Postgres, recursive CT queries, support for multiple schema, asset compliance, and so on.
Very nice. So as you, yeah, whenever I ask that question, there's always a few obvious ones that pop up, like performance at scale. Yeah. And it always feels like the list kind of keeps going because there's all these other things you need too around, again, the distribution and the cloud service outages and everything. So I think that list makes perfect sense. So based on those requirements, my understanding is YugabyteDB was definitely one of those databases you looked at. There was a couple others as well that were in consideration before you got into your testing phase. Is that correct?
That's right. So we shortlisted 2 more databases besides Yugabyte database. We evaluated based on the ease of maintenance, resilience, and we also ran a few performance testing to come to a conclusion.
Perfect. So maybe let's talk about that again. I think there's a lot of folks in the audience that again are in these phases of evaluations and thinking about testing. So once you kind of came up with that short list, you got into the hands-on portion of kind of getting in the lab, running some real tests, and that's really where the fun starts. And you can see if all the stuff us in the marketing department says is actually true, and if you actually have something that'll serve your needs. So walk us through your journey of testing YugabyteDB and kind of what are those key steps you made? What were those things that you looked at in that testing phase?
Sure. So first we began doing POCs with the database universe, which was created on Yugabyte managed cloud environment. This was a basic test. We wanted to basically test how quickly we can spin up a database. Okay. Then with help of Yugabyte team, we did a resilience testing wherein we ran a script loading records to a table on one side, and on the other side, we brought down a node from the cluster. The other nodes took over fairly quickly. Later, we moved to installation of Yugabyte database on our own VPC. We ran some performance benchmarking with Broadleaf Commerce platform. Though it wasn't a full-blown holiday stress test, but we were able to get a fairly good response time in comparison to other databases. Then we did few more POCs like loading bulk data through copy and the loader commands. We were able to load 5 to 8 million records in a few minutes. And then, we did some POCs by connecting our services to the YSQL and the YSQL interfaces of Yugabyte to see how it performs and so on.
Nice. And you mentioned YugabyteDB Managed, and that's our fully managed database as a service offering that we manage in the cloud. We also have YugabyteDB Anywhere, which is the self-managed offering that you can install in your own data center to kind of build database as a service. It sounds like you were able to leverage the cloud for some of the early testing, and I assume that helped you just accelerate the testing, kind of minimize some of that early work in some of those initial tests. Is that true?
Yeah, that's true. We did our basic evaluation with Yugabyte managed database. We did failover testing and some part of performance testing on their database as a service. But we quickly moved to self-managed config because that's what the path we wanted to pivot towards.
Makes sense. And as you were going through these tests, I kind of have to ask, was there, again, it's a lengthy process where you kind of usually get to the end and then you evaluate it, but as you were going through it, were there any of those aha moments? Again, distributed SQL, it's a new approach for a lot of folks, so you kind of changes the game of how things were done before. But any moments that stand out to you as kind of being like oh wow, this is different, or this can help us?
Yeah, there were many. The first aha moment was, finding the fact that with Yugabyte, we can have both SQL and the NoSQL interfaces, which made our setup for the evaluation pretty easy. The next was in the failover testing to see within a few seconds how quickly the peer nodes were able to detect the master leader node failure, and they re-elected the new master leader among themselves. And then the final was our performance test, where we were able to achieve an average of less than 5 millisecond response time for one of our card related operations, which was pretty awesome.
Nice. In that latency, I mean, as you kind of scaled out, I mean, that's where you got that performance at scale, right? Like you were able to maintain that latency regardless of how much you grew that system, correct?
That's right.
Yeah. Perfect. One other thing kind of thinking that comes up a lot is and a lot of people say, I mean, the technology is definitely a hard part, but the organizational side of things, like kind of aligning people and changing the mindsets to maybe these new processes, new ways of doing things, just the fact that you can scale and you do all these things that were harder before. How have your teams evolved? How have you kind of addressed some of the people, the human, the organizational side of things as you've evolved your database strategy and journey?
Yeah. Earlier, like any change to a production, it was a big event, right? And database changes are even more difficult. But with modernization, we can now have lean teams. Teams can make changes faster and independently. All services are loosely coupled, so if one team want to go live before another, they can quickly do that. They can deploy faster. They can deploy anytime. So we moved from monthly to 2 times a month to weekly, and now in future we should be able to deploy a change to production whenever they're ready, anytime. So that's our goal.
Very nice. Well, that's incredible, Lokesh. Again, I mean, I think, again, we kind of walked through that evaluation and that testing, and again, just some of those larger transformation journeys you're on, just the convergence of cloud microservices, databases. It's definitely, again, what I talk a lot about is just that full end-to-end stack of having those three pieces of cloud, modern data layer, and then of course your applications on top really gives you that flexibility that people want with the cloud. So maybe kind of final thoughts as we're getting in our last minute here. As you think through, again, talking to other people, thinking about this journey, getting ready to walk in your shoes that you just went through, anything else that they should know? Any kind of closing words of wisdom or thoughts, advice for them?
I would say that, splitting a monolithic database to move to a distributed database is a very complex process. Database objects in monolithic are very tightly coupled. We have to consider issues like, data synchronization, consistency among nodes. And also if we get strong consistency, we may have slower performance, right? So need to select different topologies for different kind of workloads to, have a trade-off between performance and consistency needs of an application. So on.
Yeah, no, I think that's well said. That balance again of kind of factoring in all these things is important. And we didn't talk about that deployment flexibility. I know that was part. We'll have to save that for follow-up conversation as you guys are doing some really interesting things with the different deployment topologies.
Yeah, we just started. It's a long way to go.
Exactly. Awesome, Lokesh. Well, with that then, thank you so much for joining us. We're kind of at the end of our time here. Really appreciate you joining us for Distributed SQL, sharing again just the beginning starts of your journey. We're going to be thrilled to track the progress, to see how this continues to go, and we'll welcome you back anytime. So with that, thank you again. Really appreciate you joining us today.
Thank you so much. I'll be glad to come back for another
Excellent.
talk.
Thank you, Lokesh. Everybody else, enjoy the rest of DSS today. Thank you.
Thank you.